In this video we're going to look at the second variation of a functional of two variables, so the same type of functional we've seen in the previous video. Now we've seen this equation here before. Now it's derived, and if you click on the link just above here you'll see the derivation of this. So this is the second variation of a simple functional. Now what we're going to do now is we're going to extend this function here of a variable x to a function of a variable x and y. Now we're not going to work through the full derivation because it's long and it's tedious, but I'll have a set of notes and I will photocopy them and make them available to you. So if we were to look at initially two variables x and y, then if we were to give the variables and the derivatives, then we write them down in this format. So if the first one is q1, the second one is q2, the third one is q1 derivative, and the fourth one is q2 derivative, then we could write down the variations in this form here. So for example, f11 would be partial squared f by partial, and it would be f11, so it would be q1, which would be partial squared q1. And for example, f12 would be partial squared f by the partial q1 by partial q2, and so on and so forth for f13 and f14 and f23, f24 and f44. Now when we work out the variation of this functional, we get the variation in this form here. So you can see that it quickly gets very complicated. So we'll just note down what the results are for the Legendre test, and this is directly analogous to what we did on the previous simpler examples in the calculus of variations and the first set of lectures that I did. So for the Legendre test for two variables, one, the range t0, t1 is going to be small. Again, I put a question mark next to that because we haven't covered in this instance here what we mean by small, and we will cover that in the next video when we look at the conjugate points. Secondly, f22 and f44 got to be a constant sign on the interval t0 to t1, and the f22 times f44 has got to be greater than f24 squared. Then if that is the case, then if f22 is greater than 0, then the stationary value will be a minimum, and if f22 is less than 0, the stationary value will be a maximum. Now what we do is we'll extend that to n variables. So again, if the range is small, and we'll look at it again and when we look at the conjugate points in the next videos, then partial squared f by the partial qr squared dot, where r is equal to 1 to n, is of constant sign on the interval ab in the interval t0 to t1, and if partial squared f by partial qr squared dot times partial squared f by partial qs squared dot is greater than partial squared f by partial qr dot partial qs dot all squared, where r is equal to 1 to n and s is equal to 1 to n, where r doesn't equal s, then we're able to say that if partial squared f by partial qr squared dot for all values of r is less than 0, then we'll have a stationary max, and if partial squared f by partial qr squared dot for all r is greater than 0, we will have a stationary min. Now these are really just the statements of we haven't actually proved these statements. So now I'm not going to prove them here in this video, but I will go through and have a look at them in a book by Forsyth, who has got these derivations done. So I'll probably give them a go and try and derive them, work them out for myself, and then I'll head in and have a look in the Forsyth book. So that's all there is for this video. In the next video we're going to go and have a look at conjugate points, and again it's just a cursory look because this is kind of advanced stuff and it's meant to be an introductory course, so we don't want to be covering all this in massive detail. It's just to give an indication. Okay, so thank you for listening and goodbye.